So taking apart things can be fun. Here are a few stills from his book. Hopefully this works. So we have a typewriter. A bicycle. And these are the sorts of exploded view diagrams that used to be common in catalogs. You might remember Sears catalogs from decades ago. I've encountered them with things I bought from Craigslist. But pictures like this used to be sort of a common mental image for everything that we owned. This is the bicycle for our mind, the personal computer.
I'll bet that Mac had a right output.
Right next to the crank.
Yeah, exactly.
Here's one from Intel, and from transistors to memory cells, modern processors like this one have billions of engineered parts. They tend to be singularly engineered and duplicated by software, but still amazing. Old rotary phone. Film SLR. This is a film SLR camera.
Chris, where did you pick this from?
So these are from artist Todd McClellan, the same who did the video earlier.
Does he put these things back together?
He doesn't say.
Yeah.
This one I'm sure is familiar to Rochesterians.
Sitting down and turning your head the wrong direction. Let me just flip this over to the other side. Because it's hard to hear you. Try to.
Can you all hear me better now?
So what do you think takes longer, taking apart the item or getting the layout just right?
So we'll get to the layout. There's actually a word for that. That's in a couple of slides. This one is particularly fitting, seeing as where we are. And so the act of arranging things, the vocab lesson, is called knolling. And it's to arrange like objects in parallel or 90-degree angles as a method of organization. And it comes from architect Frank Gehry's studio and was formalized by sculptor Tom Sachs, who I also have a video from, which hopefully will work.
What's the word again?
Knolling?
With a K?
With a K. It's, nope, this is, there we go. Where is...
Bullet 8. Always be knolling. How to knoll. 1. Scan your environment for materials, tools, books, music, etc., which are not in use. 2. Put away everything not in use. If you aren't sure, leave it out. 3. Group all like objects. 4. Align or square all objects to either the surface they rest on or the studio itself. A perfectly knolled table.
So, I don't know why it's duplicating, but we have a problem, and that's that we manufacture too many new things. The average lifespan of a new electronic product is getting shorter with time as consumers upgrade cell phones, computers, tablets, and every other gadget more often. This is environmentally harmful. In countries of manufacture like China and Thailand, industrial effluent contaminates soil, groundwater, and air. From heavy metals to volatile organic compounds, the brew is diverse, and these chemicals can be either directly toxic or more subtly harmful as mutagens or endocrine disruptors. We also tap natural resources to build things that will become obsolete at a timescale measured in months. Plus, there's the issue of buying too many electronics, something I'm sure none here are guilty of, finding space to store them, and then finding additional space or industrial capacity for disposal or demanufacturing. This slide is really garbled. But the solution is, of course, to reduce, reuse, and recycle in that order. Reducing consumption, reusing working items, and recycling items that are no longer functional. But there are two more that we can add: repair and salvage, something I'm sure most hams know about. Before we get there, we should look at what happens to electronic waste from the average consumer. The complete product material life cycle looks something like this. Raw materials are made into products, which are eventually deconstructed back into constituent materials and recycled into stock to be manufactured into new goods. The process is not perfectly efficient, of course, but it beats burying millions of iPhones and laptops in the ground. So where does the waste end up? And what does demanufacturing look like? Here's a clip from the documentary Samsara that illustrates the breakdown of electronics in an American factory. Yeah, I think the software stopped outputting. But most consumer electronics are ground up and broken down like this before the constituent materials are extracted. And so it takes a lot of energy and effort to make things, and then quite a bit to separate them out again.
In terms of efficiency, do you have a percentage of what we use?
Something that completes the cycle, it depends on the material. Something like aluminum is almost perfectly recyclable, so much so that we're nearing the point where we can stop mining aluminum. And that aluminum that it re-enters the supply from cans and vehicles is almost enough to meet demand. That may change if vehicle bodies switch to being made from aluminum instead of steel. But other things like plastics are recyclable in a smaller percentage. It depends on the type. Some can be melted down and reused almost an infinite number of times. Others can really only be burned as fuel for other types of resource recovery. So where does waste end up? Increasingly, the answer is China. Pallets of e-waste are shipped by barge back to their country of origin. And what does it look like there? Anything from the factory clip we last saw to methods that are vastly more primitive. This is a shot from Canadian photographer Ed Bertinsky, and it shows a site that's reasonably common in rural China, and that's the manual disassembly of discarded electronics. So with pliers, snips, and hammers, workers pry off all the components that were carefully soldered onto circuit boards so that they can salvage the trace elements like gold, cobalt, and tantalum. And so demanufacture like this can give us certain resources, but what do we really get back? In aggregate, the greatest constituents are plastics, refractory oxides like the fiberglass and ceramics that make up circuit boards and chips, as well as copper and iron. Things like tin, lead, nickel, aluminum are all represented in pretty small fractions. And the recovery process varies by constituent. Some things, like I mentioned, aluminum can be recycled with minimum complexity and are almost 100% recyclable. Other things like plastic, it varies. This flowchart shows that there are multiple steps required to recover usable copper when it's been tightly integrated into electronic scrap, and so they have to put it in several furnaces and then electrolyze it just to recover reusable copper. And so this is a problem, but how can we fix it? The problem is that people don't fix things. When things are broken or strangely designed, people are now inclined to throw them out or call warranty service rather than repair or customize them themselves. An example is that my parents have this refrigerator, and it has an annoying feature. In order to encourage energy conservation, it beeps at you if you leave the door open for more than 10 seconds. So for unloading groceries or rearranging leftovers, it's super annoying. My immediate instinct was to unscrew the front panel and desolder the buzzer. But unfortunately for my parents, they care more about preserving the warranty than stopping the buzzer from happening. So in a sense, they have lost ownership of their refrigerator. If only they could fix it. But what if we can repair? What if we can salvage components like motors or capacitors? Then we can reduce the amount of electronic waste, give life to new gadgets, have parts for new projects, and save some money for radios. How can we encourage repair and reuse? And of course, the answer is education. So as Gary mentioned in his intro for the talk, shade tree mechanics are long gone. If you've opened the hood of a new car, you may have seen something like this, just a plastic dust cover with everything hidden. But why is that? There are a few reasons. It's partly technological. With integrated microcontrollers, things like cars and appliances are less accessible to their owners. It's partially cultural. We're disconnected from those who build or repair things themselves. And it's partly educational. Many high schools have done away with shop classes or other activities that show it's okay to get your hands dirty and break things and take things apart. It's not all on the consumer side, though. Manufacturers are producing goods that are less durable. It's not necessarily due to malevolent intent like planned obsolescence, but often due to cost consciousness that comes from a globalized world. More powerful computers have enabled us, through simulation, to better estimate the wear and mean time to failure of mechanical and electrical components. Items can be designed to perform for a duration that matches the period they are imagined to be used, or one that better suits quarterly earnings. Where we chose components that would be seen as reliable in the past, today we can dial in part selection to better reflect the price point or reliability desired by a manufacturer. So the ethics of cost minimization are left as a debate, but it's true that in today's globalized world, competitive pressures drive a push toward minimal cost, and by extension, reliability. But it's not all bad, since minimization of cost often also reduces resource use. It's changing, though. With the maker movement, people are relearning how to use a soldering iron or turn a wrench. Publications like Make Magazine are popularizing what the DIY lifestyle used to be. And Make shows many things: how to program microcontrollers, build DIY rockets, introduces people to robotics, woodworking, even sewing. There are maker fairs across the country and maker spaces where hobbyists drag out their projects to share them with the world. Most readers of Make have a technical education, though. The advertising prospectus for Make mentions that 80% of its readership is college educated and 39% have advanced degrees. So a full third have technical job titles. The projects in Make certainly don't require graduate engineering education to pull off, but society at large isn't reading Make. Those who are learn somewhere along the line that it's okay to pick up a screwdriver or sit before a sewing machine. In his book on makers, tech author Chris Anderson makes the connection between the loss of DIY maker repair ethos to the fact that shop class and the industrial arts are no longer in the curriculum of many high schools. But he does talk about how today's renewed interest in these things comes from modern technologies like 3D printing and free software that are enabling a new generation of makers, hobbyists, and tinkerers, many of whom may not attend engineering school. People are learning to use these tools to scratch their own itch. They can make things to fix things around the house or create art. So I'll ask again, why don't we repair? The answer is that we're missing the manual. Repair knowledge used to be generational. Unlike products from a 50s era Sears catalog, most things today don't come with exploded view diagrams that show how they're put together. Many do not include replacement part numbers or repair instructions. And in some categories, disposable goods are the norm. iPhones get upgraded every 2 years, televisions grow larger, and even barbecue grills see new models. So we're hoping to be the manual. There's a community desire for DIY information, as evidenced by publications like Make, and also by websites like Hackaday, Instructables, and iFixit. Where Hackaday is often focused on reuse, Instructables on new work, and iFixit on repair, Take It Apart will be focused on these, but also on education. We want to expose the engineering and the industrial design that go into the things we use every day. So what's Take It Apart about? It's about disassembly and explanation. We want to be the manual on how to take things apart, the source where anyone can see or share information on how to repair or to learn the engineering principles behind something. It's a social how-to website where anyone can upload video or photo-based disassembly guides. From a broken washing machine, a grandfather's watch, to an old model train, the latest gadget. In disassembly, there's commonality with the crypt robber, the historian, the plumber. In each turn of a screw or careful pry exposes the artistry of engineering and the beauty of design. By taking things apart, we can see how they work and find ways to repair. We can also learn. A disassembly guide on Take It Apart includes step-by-step photographs of the disassembly process, along with text descriptions. Rich hover-over image annotations can show users troublesome screws, microchip part numbers, and detailed locations. Users can carefully search for specific guides or casually browse. And for those to get out their with an urge to get out their screwdriver, it's a new community. So I have a demo here that I'll play.
This is takeitapart.com. Here we are looking at the development server. The production server will be a bit more snappy, but let's see what we have. So upon landing at takeitapart.com, you can see a few guides that have been featured or recently created. You can browse for guides, you can create one, you can search for guides by title or description, or you can look at some tags. So handheld appears to be the most popular. Let's see what's been taken apart. So here we have two guides, one for a calculator and one for a handheld radio. And let's look at the TI-89 calculator. So this guide is a pretty good representation of the functionality that's available through Take It Apart. You can include the tags that we've seen before, and each guide has a descriptive block at the top that's useful for describing how difficult it was to take something apart, mention of the features of the gadget in question, or if you reverse engineered something, this might be a place to summarize your work. But each guide is intensely visual. It's a collection of images and videos, and so let's look at a few from this guide. This picture has a notepad icon next to it indicating that there are hover-over photo notes, and the author in this case was instructing not to strip the screw that holds the cover on for the memory backup battery. So hover-over notes are great for noting troublesome screws or for indicating microchip part numbers or parts that can be replaced, as well as instructive texts about which tools to use or how to remove things. You can also navigate using the J and K keys on the keyboard. In this case, I'm scrolling. And then at the bottom of the guide, there's an aggregate list of the tools that were used during the disassembly. Just a Torx T5 bit in this case. But if we scroll back up, we can see that on the third image there's a tools tab, and so that's where this tool is used. And so that's helpful if you want to see which tools you would need to also take something apart that's on the website. But let's look at the radio. So this is the Baofeng UV5R radio. It's a surprisingly inexpensive radio that is pretty well built and works reasonably well for something that's from a no-name brand. It's a standard 2-meter, 70-centimeter handy-talkie radio, and let's go through its disassembly. So the radio itself is pretty small, fits right in the palm, and it has a nice clip on the back for putting it on your belt or your pocket. It has a lithium-ion battery pack that holds 1 amp hour of charge, I believe. And upon taking off the battery, you can see this large metal plate. And so we'll see what that is in a second. Removing the clip. Hover over note here is indicating that we used a T9 Torx bit. And the clip that retains the battery actually fits into notches on the metal plate itself. And so all the components are designed to integrate pretty tightly together and well with each other. So there's quite a bit of engineering went into the mechanical aspect of this radio. So let's unscrew everything we can find. There you can see where the battery retention clip rests. The metal faceplate is a nice little feature. The volume knob just slides right off the potentiometer, and the retaining collars unscrew. It was pretty easy to do with a pair of needle nose pliers. And then you can just pry out the main circuit board and the metal plate. And you can see the main button sheet is one piece of contiguous silicone, which is nice. Don't have to worry about losing any buttons. The calculator had individual plastic buttons for each button. Each switch is one of these rubber dimples here, and you can press them right on the circuit board and feel the click. And then we'll remove all the screws that are holding on the metal back plate. At this point, it's pretty obvious that it's an RF EMI shield, but let's keep going. And so most of the screws came out easily, but 2 were hidden underneath this white panel, which is the backlight for the LCD screen. And so that one actually had to be desoldered. But that was the only part. And so this was a pretty easy disassembly. Then lifted right off, and then we could remove the remaining 2 hidden screws. The circuit board hinges away really cleanly. It's important to start with the side that includes the volume potentiometer. And then we can look at the chips. And so this was indeed an RF EMI shield. And so this is one of the chips on the main board, actually the only one that was labeled RDA 1846, so you can look that up at your leisure, but let's keep going. And so the board itself was pretty nice. It appears to have been gold flash, I'm not sure how many layers, but on the whole, pretty reasonable quality. The LCD backlight was very easy to desolder, which makes me think that it was a lead tin solder and not the new silver solder. But that's good for hobbyists, if not the environment. And so there are all of the parts in the radio. I was also curious about the charger and whether the protection circuitry was located in the charger itself or in the battery pack. Since it's a lithium-ion battery, it's important to have somewhere. And so we took this apart, and there's actually not that much there. But you can see this chip, the HXN WS1195, and otherwise it's a pretty simple board. So it appears that some of the protection circuitry is likely a charge controller. That most of the protection circuitry is probably the battery pack itself. And then you can see the 2 tools that we use that were unusual, the Torx drivers. And then you can leave a comment on each guide or reply to a comment. And so that's the Baofeng radio. And this is takeitapart.com.
Yep. So the site's not live yet. The question was you need to subscribe to it. And you don't. When it is live, anyone can go there and see and learn. And so anyone can also post information. So our business model is licensing the back-end software for other purposes, but Take It Apart itself will be free to use.
Was it your call sign in the back of the radio?
Yeah.
Did you get it back together?
I did. It works fine.
That's good. And who's PJM? The calculator got too damaged. He's still testing you for taking it apart?
Tim, he's one of the other guys working on Take It Apart.
Do you have the option to upload data sheets? I know that the RDA uses for the distribution of the
You don't have the option to upload data sheets yet, but you can certainly link to them. Other file types are something we're working toward.
Over there.
Do you reference other sites that take things apart, like designing news, like maybe different parts from the Apple iPad and iPhone? Do you reference those, or do you take those apart?
So everything that would appear on Take It Apart would either be taken apart by ourselves or submitted by a user of Take It Apart. So if someone had taken apart those same things, they could upload the content. We wouldn't be borrowing it from other sites. Though if we did take it apart, we might link to their disassembly as well, so you could have a different perspective. And so what have we learned taking things apart? Sorry.
So, is there also a site that says how to put it back together?
Well, that's the joke. We like to say that you can just reverse the order of the pictures. But that's actually how I got started with this. Was I would take things apart and take pictures as I went, so I'd have a record of which screws went where. And when I was done, I had all these photos left over with nothing to do with them. So I put them up on a blog, figuring that they might be useful to one person out there somewhere. And the response turned out to be phenomenal. And it was featured on the BBC World Channel for a while, and we got a lot of hits. So it seems that there definitely is an interest in information on how to take things apart. Any other questions? Let's see. So what have we learned? This is something that's kind of interesting. This is a Bose home theater receiver, and the case of it is plastic, but it's actually conductive. And so if you measure with an ohm meter between 2 points on it, you see very little to no resistance. And so it turns out that as an alternative to using metal cases to shield things, you can buy this spray. It's made by a couple different companies. MG Chemicals makes one. That's some kind of conductive powder, like silver or graphite, mixed in with acrylic paint. And it's sprayed on the inside of cases to provide some shielding and some grounding. This is something that we found to be absurdly simple, and it's an amazing what we'll sell. This is an X10 home automation product, and it's designed to couple together the two 110 legs that come into a house so that X10 automation signals can propagate from one leg to the other to all devices in a home. And it's really just a capacitor and a resistor in a box with some thick conductors. And classic electronics were beautifully built. This is an old HP function generator made from through-hole components with a gorgeous gold flash board. And the traces shine probably just as well as when it was new. So maybe some of you have used one of these. This is a GPS receiver with a helical antenna, and it's cool to see that the antenna appears to be made from a single sheet of flexible circuit board that was photolithographically etched. So just like regular circuit boards are made, they etched this antenna and then wrapped it around to make a helical antenna. And taking things apart can also be useful before you buy something. And so these are pictures of a KitchenAid mixer. And depending on which line you buy from KitchenAid, some are sold with plastic gears and other with metal. And the plastic ones are much more prone to failure. And so by having knowledge of things taken apart, we can see which is which. And I also have learned from taking things apart that I have a lot of respect for the engineers who design printers. With so many injection molded gears, rubber belts, and motors, it's amazing how well they work and how inexpensively they can be produced. There's some of the few things that I have a lot of trouble putting back together. So what progress have we made in sharing education with the world? Take It Apart had a booth at the World Maker Faire in New York City last fall, where we supplied a steady stream of donated and largely non-functional gadgets to be disassembled right at the fair. As visitors turned screws and pried panels, we explained what different components would do, why things might fail, and for the particularly interested, why some of the products were designed the way they were, as far as details for manufacturability and other factors. And the reception was outstanding. In a world where people are afraid to work on their cars, it was nice to see people turn screws in a low-risk environment. We had thousands of people stop by, hosted a few school groups, and even got a mention in the New York Times. The world wants to know, it seems, how to take things apart. So I invite you to visit takeitapart.com and put in your email to sign up to be notified when we launch. I promise we won't spam you. I'll probably send out one message before we go live. And once it is live, you're welcome to author your own guides of things you've taken apart, maybe radios, home appliances, and share your knowledge with the world. You can also talk to me after, and I'd be happy to give you an early access beta code. I actually have another video about creating a guide. If anyone's interested, I can show later. I can go into the technical details if anyone is interested of how Take It Apart works or the software behind the scenes. Otherwise, you can flag me after, and I'd be happy to talk about the challenges.
I'd like to see that, but I have two questions. One of them is relevant to what you just said. So if I wanted to upload a guide to take something apart, do you have a guide to how to make my guide? I mean, do you want it broken down to every last component? Is there something I need to do to make it suitable for your site?
So we have a direction document that will be on the site that encourages you to post certain types of information so that both it shows up, the guides show up in search, and so that it's complete for other people. But because you may not know everything about a product, we're working on wiki functionality so that any user of the site can also add information to other guides.
I'm going to guess that some people here are expecting really cool stuff.
I bet.
I'd like to just assemble and put up there. The second question, you mentioned a while ago, and I just let it go. You mentioned the maker movement and maker spaces. Could you elaborate on that? Are there maker spaces in Rochester?
So a maker space is like a community gym. But instead of working out, you might go to this room and use a table saw or a 3D printer or a soldering iron. And there are two maker spaces that I know of in Rochester. One is Interlock Rock in the Hungerford building. And the other is, I believe, just called the Rochester Makerspace, which is pretty new. That one appeared while I was in California last year.
St. Paul. I actually went there last night because I read RARA.
850 St. Paul Street, apparently. I know they have open houses on Thursdays, I think. RochesterMakerspace.org. Very cool.
What's the other one?
The other one is called Interlock Rock. And I'm not sure what their schedule is like, but if you Google Interlock Rock, they'll show up.
So when I was a teenager, we had community darkroom where people could take photographs on film and bring them there and use their equipment and their largers. You guys can, it's like that. It sounds like it's like that. You pay a fee to be a member and use their stuff?
Most of the makerspaces have some kind of membership fee, and along with that, they track your training so that they won't let you use a laser cutter right away. They want to make sure that you won't break it first.
But it sounds just like a community darkroom that we used to use.
Yeah, similar idea. But yeah, for capital assets that one person can't afford to own, it's a great thing. If you just need a milling machine for half an hour, you can go and make something. So, like I said, I'd be happy to talk about the tech details. But that's all I have. So, any questions?
I have a question, more of a sociological question. If you look at the guys in this room, when you offer them, you can buy something new for $100, or you can buy something crappy for 10, and we're going to spend $200 to make it work. Most of the guys in this room will say, why do I want something new when I can fix it? But if you look at our age, we're older, we grew up like that. I saw a lot of young people like this major space last night. Is this a new phenomenon that's a flash in the pan, or do you think this is going to keep going?
I certainly hope it's durable change, and I'm hoping that sites like Take It Apart and Instructables will do their part in getting the internet generation to fix things and take care of the things they own.
Do you think it'll have an impact on industrial design or actually design stuff to be taken apart and fixed and recycled?
So the question was, do I think it'll impact the way that things are industrial designed? I hope so. A lot of things that we take apart have one-way plastic snaps now, and so they're designed to be put together and never repaired. And so they might, if you try to take them apart, the snaps break, and then you're left with a circuit board and a couple of pieces of injection molded plastic. So I'm hoping that if people start to care about these things, at the very least they'll push manufacturers to make things repairable so that they can be sent in, if not able to be fixed by customers themselves.
Problem is finding parts for any of this stuff, even regardless of what your
working on it. You're working on a motor, you're working on a snowblower, you're working on a saw, skill saw. They won't sell you the parts.
It can be a problem to find parts. That's things like eBay are helpful for that. You can find parts, as well as new technologies like 3D printing. They're not quite there yet for replacement parts for everything, but there's another website called Thingiverse for sharing 3D models that people have created. And so if you've come up with a holder for something in your garage or a part of a machine that you can make using 3D printing, that you might upload it to Thingiverse and share it with the world. Thingiverse, it's called. Thingiverse, Thingiverse. And for electronic components, of course, there's DigiKey and Mauser, and there's also a search engine for electronic parts called Octopart, like octopus, but Octopart.
So someone asked if manufacturers are going to start making things easier to take apart. We used to go the other way around. There's a boutique guitar amplifier manufacturer who obsolete circuit boards and some junk you can't see through, so that nobody knows how he does his magic. Think manufacturers are going to start doing that?
There's certainly a risk, especially for proprietary chips that are custom designs, probably like the ones that were on the board for that radio, where many of them didn't even have labels, and so they were probably designed specifically for that series of radio. As far as making things more difficult, people will find a way. There's a company in Canada called Chipworks, and they actually depackage full-scale processors. And so then they look at them under electron microscopes and go layer by layer to reverse engineer complicated microelectronics.
The average person that bought that Baofeng UV5 for $30 or $40 on Amazon and quits, he or she's just going to throw it away and buy another one. I mean, that's just a disposable item for everybody.
Some.
Talking about hands.
Yeah. What about the capacitor plague years ago? So many things died just because they had a burst capacitor. If it's something like that that's simple, why not fix it?
I saw the abbreviation ATK. What is that meant again?
Which slide?
Towards the early part, it says ATK.
Oh yeah, so that was the video for that word. You can find that on YouTube if you search for knolling. Yep, sorry, I'm on the wrong computer. It's but yeah.
Problem is, if they build stuff that you can repair, then they can't sell a new one. That's the whole economy is based on planned obsolescence today.
It's true. Planned obsolescence is definitely a concern. But ultimately, I think companies will adapt to whatever customers push for. If they'd rather pay for a service contract on something rather than buying new things, companies will adapt to wherever their profit comes from.
At the fair in New York, what give us some comments? Because you see people that are young and old taking them apart because they have this is fun, others say you can learn this at school.
The Maker Faire in New York is an amazing cross-section of New York City population. People from all over the world, actually. And people young and old, technical, artistic. It's really a fun place to walk around. And it's not just technical. And so there are people there who are doing interesting art installations, sculptors, as well as robotics and 3D printers. The group next to us was playing music using chip-tuned electronics, and it's just a really wild environment. I really encourage anyone to check one out. There's one in Buffalo in March, the first week of March, I believe. The Buffalo Mini Maker Faire. I think it's at the Science Museum.
What is the next one that the Maker Faire are using next year?
They're usually in September. And if you search for Maker Faire, they'll come up. Fair with an E. I believe that Buffalo is the nearest one to here, yeah. There's not a Rochester Maker Faire, though maybe we could change that.
Any other questions, Chris? All right, well, I'd like everybody to thank them for two things. One, for getting over the technical difficulties. Thank you very much. That took some Herculean efforts, and the others for the presentation. Thank you very much.
And thank you for listening, everyone. This is the first RARA meeting I've been to, so
There you go.
it was nice.
Now you're stuck. We're going to expect you every month.
Have to study up for the next license class.